Hi, so do you remember the unit circle? There's the graph of it, right? It was centered at the origin, passes through the points 1, 0, 0, 1, negative 1, 0, and 0, negative 1, right? Circle with radius 1. So maybe you remember when you did this unit circle that at any point xy on the circle, right? So just call any point on that circle xy, the value of x was equal to the cosine of the angle theta, and the value of y was equal to the sine of the angle theta. Now you're going to say, well, what was the angle theta? Well, what we had said was theta was the angle formed by the positive x-axis and the ray that connected the origin to xy. So like if you had a scenario like this where you're calling this point here xy, we had called this angle here theta, right? That was your angle theta. And we always went counterclockwise, right, for a positive angle. Now, realistically, what the angle really is the distance around the unit circle, right? So like if you're calling this 0, right, that angle there is roughly pi over 4. And then when you get to there, you've gone a quarter of the circle, so that was pi over 2. Then when you've gone here, that's half the circle, so that was pi. Then you got here, that was 3 pi over 2. And then you got all the way back around to 1, 0. And then you've gone once completely around the circle. And the circumference of the circle is 2 pi. Therefore, you've traveled 2 pi around the circle, right? So that was technically what the definition of the angle was. It was really the distance around the unit circle that you've traveled, starting at 1, 0, going counterclockwise. Right? And again, this is the whole reason for this. All students take calculus, right? If you remember, you would come up with this ASTC, which meant that in the first quadrant, all of the trig functions were positive because both x and y were positive, right? In the second quadrant, sine was positive, right? Because sine is the y value, but cosine, which is the x value, is negative, right? And in the third quadrant, both x and y were negative, so the only one that was positive was the tangent, because the tangent is the sine over the cosine, right? So if you have a negative divided by a negative, it gave you a positive. And then of course in the fourth quadrant, x is positive, y is negative, therefore the cosine was positive, right? So that's really where that whole ASTC, all students take calculus, came from, right? So we'll get rid of all that. So since we know that x was always the cosine of theta and y was always the sine of theta, it shouldn't be surprising that the set of parametric equations for the unit circle, if you're saying that you're starting at the point 1, 0 and you're tracing it out counterclockwise, it would just be x equals the cosine of t and y equals the sine of t, right? And you're letting t go from 0 to 2 pi, right? So you're tracing it out exactly one time. Right? Now if you wanted to trace it out more than once, you would make t go to 4 pi if you want to trace it out twice, right? If you want to trace it out 3 times, you would make t go to 6 pi, so on and so forth. And you can see that on the graphing calculator. We can do that real quick on the graphing calculator here. Like let's say we go to make sure we're in the parametric mode. We are. If we make x be the cosine of t and y be the sine of t, and let's say we want to trace out this circle twice, what we'll do in our window is we'll make t run from 0 to 4 pi, and we'll just make our window go negative 2, 2, on both x and y, right? So we'll give it a little bit of space, give the circle a little bit of space to breathe, so it won't be touching the sides of our window, right? So now remember what we wanted to do is we wanted to see this traced out. So we'll put it on that one there with the circle on the end, and now we'll see it should start out at 1, 0 and go around the circle twice. It's a little slow, and it doesn't really look like a circle, but in fact it is a circle. It's just because of the the fact that the screen is wider than it is tall, so it doesn't look like a circle. It looks really more like an ellipse, but it is a circle. So there's your unit circle traced out twice, right? And I mean, you can play with it. I mean, you can say, all right, maybe I only wanted to trace out a half a circle, so you would just make the t only go from 0 to pi, and now it'll just do the top half of the circle. All right, so that was our parametric form of the unit circle. X equals cosine of t, y equals sine t. And again, t doesn't have to be t. I mean, you could call it t theta if you want, right? The parameter, what you call it, doesn't matter. But usually we call it t. That's why I have it as t here. So now the trick is, how would you turn this x equal cosine t, y equals sine t set of parametric equations into rectangular form? Well, this is a little bit different than what we've done in changing other parametric equations into rectangular form, right? We can't just solve one of them for t, because we're just going to get like an inverse cosine or inverse sine, and that's going to be a big mess. So what we can do is we can use a little bit of trig identity magic, right? So what do I mean by that? Well, we know x equals cosine t and y equals sine t, right? We actually have this nifty Pythagorean identity that said that the sine squared of t plus the cosine squared of t was 1. And that's always true, right? Regardless of the value of t. Therefore, if x equals cosine t, well, if we just square both sides of this, what do we get? We get the fact that x squared equals cosine squared of t. And if we square y equals sine t, right, both sides, we have that y squared equals the sine squared of t. And now it's really just substituting, right? We know that sine squared t plus cosine squared t equals 1. We can replace sine squared t with y squared. We can replace cosine squared t with x squared, and it's equal to 1. So there it is. We're in rectangular form now, right? Y squared plus x squared equals 1. Or, as it would normally be written, x squared plus y squared equals 1, right? So that's what we call our rectangular form of the unit circle. And again, more specifically, it's known as the implicit form, right? Because it's not solved for y or solved for x even, right? It's just given in that form, y squared plus x squared equals 1. Now, could you solve that for y or x? You could. The problem being is you'd have to take a square root, and when you have to take a square root, you'd end up with two separate equations, right? A positive square root equation and a negative square root equation. So that's why you really want to leave the circle in this implicit form, right? So x squared plus y squared equals 1.